Okay, here we go. This is our last topic in Unit 12. We're going to do our final transformation, and that would be the one and the only rotation. What are rotations? Well, a rotation is simply when something turns or spins or something like that. A rotation is a pretty simple concept. I think you probably know that already. Now, a translation is not a rotation. A translation doesn't involve any turning or spinning. Something is just moving. A reflection, on the other hand, is when something gets reflected. And then a rotation is when something turns or spins or rotates. Okay, now, reflections and rotations can sometimes look kind of similar, but how do you know that that second transformation was not a reflection? Well, check out the bite mark in the apple. If it had been a reflection, the bite marks should line up like a mirror image, right? That's how we know that second transformation was a rotation and not a reflection, because the bite mark is over here. It got spun around, not reflected. Also, you can kind of take a look at the way the leaves are pointing, and that gives you a little clue as well. So I'm going to keep on talking about some rotations and stuff, and then, oh my gosh, who is this guy? What in the heck is going on? Okay, that's strange. I don't know where this guy came from. And now his head is rotating around. Well, I might as well at least tell you that his head just rotated 90 degrees clockwise. Oh, why is that considered a 90-degree clockwise rotation? Well, it's considered clockwise because it moved the direction that the hands of a clock move, right? In a circular motion in that direction. And it's considered 90 degrees. I think you can probably see why that's a 90-degree rotation, because it was like a 90-degree angle, right? Can you go 90 degrees counterclockwise? Wow, what's he doing? This crazy guy, I don't know what the heck is going on. Can you go 90 degrees counterclockwise? Yeah, you can go 90 degrees counterclockwise. That's fine as well. But when we say a 90-degree rotation, what we usually mean is a 90-degree clockwise rotation. Can you go more than 90 degrees? Sure, you can go 180 degrees. And these are all different kinds of angles of rotation. And you don't have to just go by 90s. You can go a little tiny 30-degree rotation if you want to, or you could make a big, huge 200-degree rotation if you wanted to as well. There can be lots of kinds of angles of rotation, but the common angles of rotation would be when you take an object and rotate it 90 degrees, it's like a quarter of a full turn, and 180 degrees would like be a half of a turn, and then 270 degrees would be like 3/4 of the way towards back to where you started. And you don't have to do those. You could go like half of a 1/4 turn, and that would be half of 90 degrees, which is 45 degrees as well. I don't think any of this stuff is that complicated or complex. You probably know a lot of this already, but let's apply it to geometry. What if I took this trapezoid? No, I don't want to rotate the whole trapezoid. Let's say I just want to rotate point B. If I just want to rotate point B 90 degrees, I can rotate it 90 degrees. And then instead of that one quadrant of the graph, it's going to be in the other quadrant of the graph. And then I could rotate it 90 more degrees to go 180, and now it's in the other quadrant. And then I could rotate it 90 more degrees for 270 degrees, and now it's in the other quadrant. And you know you did this right if you do full 360 degrees and you end up right back where you started. So I've got a question for you. Practice problem number 1. Where would point A prime be if you took point A here and if you rotated it 90 degrees? Where would you end up? Where would your transformation lead you if you started at -2, 2, and then went 90 degrees from there? Or how about this? I got another practice problem. If I started with point X and then I ended up with point X prime, how many degrees did that thing get rotated? Okay, now that you've thought about that a little bit, let's talk about one final topic in symmetry. And we talked about symmetry with reflections, but you can have symmetry with rotations as well. Like some objects can stay symmetrical to itself when it rotates and spins around. Like, for instance, if you took this object and rotated it 90 degrees, isn't it the same object basically? Yes, it has what we call rotational symmetry, and it can go another 90 degrees and another 90 degrees. This figure has rotational symmetry because it's the same figure even when you spin it sometimes. How about this? This figure does not have rotational symmetry. Why not? Because that's not an M anymore. That's not an M anymore. That's not an M anymore. In order for it to be an M, you have to go 360 degrees, which is just where you started. So that doesn't really count as a spin. You can't really spin the letter M and have it stay a letter M, so therefore it does not have rotational symmetry. All right, practice problem number 3. Does the letter H, capital H, have rotational symmetry? And if so, how many degrees would you have to turn it to make it symmetrical to itself? If you can handle that problem, I think you're in pretty good shape. So we are done.